We're going to head and get started. My name is Aaron Gunnarsson with PHMass. I know most of you at this point recognize your names and your faces, but to the new folks, welcome. Thanks for joining us for our monthly presentation. We do these on the second Tuesday of every month. And as usual, these are being recorded and will be posted to our video library later on. So you can reference these or refer them to others to watch. We have a lot of great sessions on there. Everything we've done in the past is pretty much up there. So if you want to catch up on past sessions or see different case studies or things that you missed, definitely go to phmass.org and look up that video library. So today we have an excellent session here on the best practices of the Passive House. I have a few updates I'm going to give here to start off with, and then I'm going to welcome Bev Craig from the Mass CC to give an update on one of their new programs that's coming out, one of their new challenges. So I'll have her talk for about 5 minutes, and then we'll jump into our feature presentation for tonight. As usual, feel free to use the chat room throughout the presentation to ask questions, kind of make comments. We'll get to some questions maybe during the presentation, but ones that we don't get to during the presentation, we'll get to at the end. And at the end, we can also use the raise hand feature, so you can ask things directly if you'd like to as well. But in the meantime, just keep yourselves on mute. And if you'd like to, share your video, you can, and we can all see your face. But that's up to you. So just a couple updates on some upcoming events. So first off, there's a verifier training coming up. I mentioned this last month as well, but we know there's going to be a demand for verifiers, and PHIUS is scheduling more and more training. So they have one that just ran in April. Now they have one coming up in July. These are virtual sessions, so they're virtual. You can do them from wherever. Though they do have some live sessions that take place. So you join them live virtually. This session is coming up in July, the week of the 10th. So they run for about 3 hours on Monday, Wednesday, Friday. But a really, really great opportunity here for verifiers. If anyone out there is looking to become a verifier or knows people who would be interested in a role like this, recommend it to them. And a reminder that these sessions are eligible for the Mass Save reimbursement. So you get 50% of this reimbursed, the cost of this reimbursed through the Mass Save program. I definitely recommend this to anyone and everyone you think should be a PHIUS certified verifier. We also have this new course that just got announced. This is a short version of the Passive House and High Performance Assembly Workshop. There's a long version of this course running right now in Newton. That's about 6 weeks. But this is just an afternoon, short, condensed version that goes over some of the top sort of principles on high performance assemblies. So this is currently being offered in 2 different dates, May 23rd and June 6th. These are free sessions being offered at no cost through the Mass Save Passive House and All Electric Training Program. They're limited enrollment. They're going to be held at the Studio for High Performance Design and Construction's classroom in Newton. They have that certified Passive House Net Zero office classroom there, and this will be held there. Limited enrollment. So I believe each of these sessions is limited to just 20 people. So if you want to sign up for these, do so quickly, but definitely make sure that you can attend. We'll be doing a lot of reminders to make sure that the seats go to folks who are there. And if there's lots of demand, more sessions may be scheduled, but for now, there's these 2 on the 23rd and 6th that are going up. And then one last update on the opt-in code. We've been talking about this, the last basically all year. So just want to give another update. We're now up to 16 towns or towns that have opted in, towns or cities. So here's the list. There's some new ones since we met last month, which is exciting to see. But it's great to see more and more towns opting in. And as folks remember, I think I have it up here, but this is kind of how Passive House is affected. Obviously, in the current stretch code, which is in existence for all stretch code towns, Passive House is an optional pathway. But for these new specialized opt-in towns, Passive House will be required for all multifamily buildings, in addition to being an optional pathway for all others. So it's great to see all these towns doing this and opting in. And next month, we should have hopefully a few more to announce. So those are the updates that I have today. I'm going to turn things over now to Bev Craig from the Mass CC to talk about their Embodied Carbon Reduction Challenge. Bev, take it away.
Hi, everybody. I know many of you are super into low operations through Passive House for buildings, but I also think a lot in this crowd are really interested in how to make the embodied carbon associated with the building materials in your buildings as low as possible as well. Next slide, Aaron. And so Mass CC, to try and encourage more building science firms that are out there. So maybe certified passive house consultants or architects or even owners who want to explore how to reduce the embodied carbon of the buildings that they are working on. We're holding an embodied carbon challenge over the next year. And there are going to be 11 prizes between 30,000 and 50,000. Part of the point of this is to pay you for your time to figure all this stuff out so that you can be recommending on all your projects low embodied carbon materials. And then also these prizes will tease out a lot of high impact, low cost changes that can be made that everybody else can be working on. Projects to apply a year from now have to be 20,000 square feet or above. So we're focusing on the biggest buildings where the most embodied carbon is. So that's where you're getting your structural steel and a lot of concrete and a lot of materials, right? And we really want to encourage people who haven't done this before, life cycle analysis, to get in the field. And so 5 of the prizes are being held for folks who haven't done those before. And to help people in this next year, we're trying to make it easy by providing free tools. So a lot of life cycle analysis tools are free, but the 2 that probably are most commonly used that are for a fee are OneClick, which I think a building science firm probably is going to be most interested in, or Tally, which is an add-on to Revit. So the architects out there in the world, this is like an easy plugin, basically, that can help you estimate the embodied carbon of different choices that you're making. Anybody who's working on a Massachusetts project that is 20,000 square feet and will be 2 construction documents by next year can go on the Built Environment Plus page and express interest, and we can get you those tools for free to work on in the next year. There's also a bunch of training that's free, and anybody can do this, even if you don't really want to be involved in in applying a year from now. And I apologize, it looks like this slide got a little screwed up. Next slide. And so, I mentioned a lot of this, 20,000 square feet or above. You need to be in design by next year at the end of March in order to apply. And it can be new construction or major renovation. So it doesn't have to be just new construction. It can be any kind. And any lead applicant can't get more than 1 award. Next slide. And so I think the main thing you need to do is just go to the Built Environment Plus page if you're interested in this. Go to the notice of interest form, and we'll follow up with you from there. And next slide. I think there's a lot of great. Oh, this is how they will be judged. 30%, 35% on replicability and cost effectiveness of the things that are included. 35% for the reduction in embodied carbon through a life cycle analysis compared to a baseline, and 30% for innovativeness. So this might be like things that you do in design at different stages that might not show up in an LCA, but could be really innovative and interesting, and sort of your process for how you talk to the owner about this. Next slide. It's free, and like I said, notice of interest. Next slide. And there's a lot of trainings already set up, and there'll be even more coming. So this embodied carbon tools overview, I think, is a great hour-and-a-half intro of a lot of the free ones that are out there that you might use at different stages of design as well. And then there's sort of deep dives into both Tally and OneClick. There'll be a bunch of office hours for both Tally and OneClick, so you can sort of bring your project to those office hours. There'll be case studies, and then there'll be a bunch offered also through the Express program, which will be any firms operating in Massachusetts under 100 employees are eligible for that for free, for $30,000 of training for free. And that's it. So if anyone has questions, feel free to throw those in the chat, and I will try and answer them as we get going on the main presentation here.
All right, thanks, Beth. It's great to see this program roll out. Excellent, thanks for the update. I'm going to actually stop sharing my screen here and turn things over to Christina McPike from Wind Companies and a new member of the PHMass board to present tonight's feature presentation on the best practices of passive house. So Kate or Christina, go ahead and take it away.
Thank you so much. Can you hear me okay?
Yes, I can.
Okay, and then give me 5 more seconds to make sure I get this right too.
No problem. And a reminder, everyone out there, please use the chat room to ask questions or make comments throughout the presentation. We can even address some live at the end.
Yeah. I've lost the Zoom video for some reason, but I think that's okay. Can you all see
We
the?
can see it. It is in presenter mode, so we kind of see the two different slides.
Got it.
Yeah.
I don't want to do that if it can be avoided. So should have done a tech check. Looks like I'm on my third monitor by mistake.
That's all right.
Display settings. That work?
No, it's still the same thing for us. Oh, there we go. This is it now.
We're good?
Just the main slide.
Okay, awesome. Sorry about that, everybody.
No problem. Just a small delay. Take it away.
Okay, great. We'll jump in. For starters, I just want to introduce myself and my colleague and co-presenter here, Kate Doherty. So I'm Christina McPike. I'm the Director of Energy and Sustainability at Wynn Companies. Wynn is a 50-ish year old family founded and operated real estate developer and property manager based in Boston. We primarily own, manage, and build mixed income and affordable multifamily housing. And I've had an in-house sustainability department for 15 years or so now, and are doing some good projects that I'm excited to present on today. Kate, can you introduce yourself?
Sure. Hi, everyone. I'm Kate Doherty. I'm a building systems consultant for Stephen Winter Associates. I work on our passive house team. Stephen Winter Associates, also 50-ish years. We just celebrated 51 years in operation this month. And we aim to make buildings better. That's our motto. That's what we're here for. And passive house is one of the great things that our company is working on, along with several other different consulting scopes as well. So I'm acting as the certified passive house consultant or designer rather, on a few of the projects with Christina, and that's what we're going to talk about today.
Awesome, thanks. So we are going to try to get through quite a bit of content. As a developer and owner, I wanted to share kind of my perspective on behalf of Wynn, sort of why passive house, especially as we consider our incredible stretch and opt-in code developments in Massachusetts recently. And looking forward, Kate will give a great overview, really kind of comparing the PHMass and PHI standards. And we'll do that in part using 2 case studies of projects that Wynn is developing that are pursuing these 2 different certification paths, and hopefully get through some of the similarities and the differences there, and really focus on the process. So a little less in the weeds on the building designs themselves, although I'm happy to talk about that. And we'll get into it a bit in the presentation for sort of example purposes. But thinking more kind of programmatically, how do projects go from conceptual feasibility stage to hopefully a successful certification over a 2 or 3 year time frame? So first of all, kind of why passive house? I mentioned before, Wynn is sustainability is not new at Wynn. We've had a whole team dedicated to overseeing our sustainability initiatives, as broad of an umbrella as I think we all know that can be. For 15 years, it's not trendy for us. It's really just good ownership in business and asset management. But it's not like we got here overnight. Honestly, Bev Craig and Masculine Energy Center and their Passive House Design Challenge from 5 or 6 years ago now was in part sort of the early impetus for us to roll up our sleeves and try to get smart around designing and building passive house buildings before it was code, and here we are now it's code, and we're finally just starting our first 2 projects. But just really high level, it's not a coincidence that a lot of the new passive house projects that we're seeing being developed are affordable multifamily housing, and in large part that's because we work in a somewhat niche financing space using the low-income housing tax credit as a financing tool, which is allocated by the state's qualified allocation plan. And thanks really in large part to DHCD and advocacy across many groups and individuals, we've seen the QAP in Massachusetts embrace passive house as sort of the highest performance standard that you can get, and you can qualify for incentives, and you can really compete with your peers in obtaining tax credit financing by committing to passive house certification. And it's not unique to Massachusetts. We're seeing that all over the country, really, and particularly in somewhat more progressive states in New England, the Northeast, and California. But for us as a long-term owner, and we own the buildings that we built in the 70s, passive house is a way of sort of future-proofing against future building performance standards like Bardo 2.0 in Boston, as we're seeing. It's a way of controlling operating expenses while sort of responsibly electrifying and getting off of fossil fuels. And then my last bullet point is kind of cheesy, but it's also true. You know, once you've seen a passive house project get designed and gone through the QA/QC process and really seen kind of what might fall through the cracks if you don't commit to passive house up front, how could you build any differently? So it's sort of, you know how to build the A+ building. Anything less good than that just feels, well, less good. So those are just anecdotally somewhat personal, or I would say not unique to Wynn as to why many people are embracing passive house as a high performance design standard. So we're going to talk about 2 projects, real projects. First one here, Hills Farm. This is a new project that we're developing in Shrewsbury, Massachusetts. It is, as I mentioned, a low-income housing tax credit project. It's a little unique in that it's a twin deal, meaning it's both a 4% and a 9% award. Not super relevant, but happy to talk about that. Mixed income, predominantly low income. It's 93 units split into 2 kind of smaller buildings, small buildings for us anyway. And being led by the project team bulleted out here. This is not all inclusive by any means, but Cube 3 is the architect, BLW Engineering, Steve Winters, obviously Kate has been part of the project team since the very inception. Sustainable Comfort Inc. is acting as the Energy Star rater and verifier, and Delbrook is our general contractor. Hills Farm is a $32 million construction budget, or about $294 a square foot, and it is pursuing PHMass 2021 certification. The second project in the exact same phase, both of these are hopefully closing this month or next month. Also a 40B project, sort of inclusionary zoning in Massachusetts, larger, 114 units in a single building, 4 stories, over a podium with sort of pseudo open parking. And a different project team. So the architectural team, TAT, is the architect of record. Peterson Engineering is our MEP engineer. Similar, Stephen Winters Associates, so also Kate's deal, and a different general contractor, Cranshaw. Total project cost is not too far off the Hills Farm project in Shrewsbury at $307 a square foot. The difference and sort of relevant piece here is that unlike Hills Farm, which is pursuing PHMass 2021 certification, the Westcott Apartments in Swampscott is pursuing certification through PHI, or the Passive House Institute, the European standard. So I'm going to pass the buck to Kate here in a second, but this gives you kind of a side-by-side comparison of the performance specs between the 2 projects. We call out building 2 at Hills Farm. Both buildings, for the record, are pursuing, will be certified. We based some of the early modeling on just one of the 2 buildings and showed this building in particular because it's the smaller of the 2, and therefore it was much more challenging to achieve passive house certification than the larger building, something Kate can get more into. But honestly, sort of doing kind of a side-by-side comparison here, again, PHIAS at Hills Farm on the left, PHI at Westcott Apartments on the right, they're pretty similar. We have a more robust wall assembly on the smaller PHIAS building. But otherwise, windows, we're hoping to use the same window at both. The roof is a little more beefed up at the PHIAS project than the PHI project. And our HVAC systems are nearly identical. Obviously, these are different capacities of ventilation, but air source heat pumps for heating and cooling. These will be our last two buildings with gas domestic hot water, where we are finally moving into the fully electric realm. But these two were still at that phase where we weren't, the technology was new, it still is new, and we were a little bit reluctant 3 years ago when we started the projects to fully commit to electrifying the domestic hot water plants. And then again, high efficiency, balanced ventilation, energy recovery units that are central to each building. And then I guess one kind of obvious question you might ask is why PHIAS and PHI? Why didn't you stick with one, or why or the other? Or why did one do this and not the other? I wish I had a sophisticated answer to that. We started with Swampscott first. This project is almost 4 years in the making, just to give you a sense of how long some of these horrible multifamily housing deals can take from start to finish. And we hired Stephen Winters Associates to do a feasibility analysis of the building, looking at both standards. Or, hey, SWA, can you tell us which one we should do? We've never done a passive house project before. We have worked with PHI on an interfit, retrofit of an existing building. And so we were more familiar with PHI as an organization at the time than we were PHIAS. But, we didn't really have a strong loyalty towards one program over the other. But the feasibility study found that in order for us, again, based on a very high level rendering, basically, that if we were to pursue PHIAS, we would need solar PV, at the time of completing the building in order to satisfy the source energy requirement. And we didn't feel super comfortable relying on the ever challenging interconnection application process and utility approval process and the evolving SMART program to rely exclusively on adding renewables here in order to satisfy our passive house commitments. And so that was the main driver for going to PHI on our Swampscott project. And then the second one was really easy. Well, we're doing PHI and Swampscott, so let's even it out and learn about both in the process and do PHIAS at Shrewsbury. We didn't bother with the feasibility study. We saw this as an opportunity as a developer to get smart about what we thought was coming as code. Good news, it is here as code. And so let's do these two dual paths and sort of maximize our own capacity building internally at WIN and then across our design and consulting teams as well. So I'm going to hand it off to Kate to do a little bit of a deeper dive on how the two standards compare.
Sure, thanks, Christina. I joke with my colleagues internally that these two projects trained me. I've been at SWA almost 4 years in August, and I've not only been working on, but these are the two projects that I've really taken the reins on. So it's been really great for me to kind of see these projects in tandem and working towards the same timeline in the two different programs. So that's been really great. So Passive House 101.5, not a radio station, but it is a really cool program. And we're going to run through the principles briefly of Passive House. I'm sure a lot of people on the call are familiar, but there might be some that are a little bit less familiar with what Passive House is and what's coming for code in Massachusetts. So Passive House is it's a rigorous, arguably the most rigorous performance-based standard for buildings. And it combines both energy metrics and then air tightness with occupant comfort. I said it, I'll say it now, and I'll probably say it again. Occupant comfort is extremely important for Passive House. And these passive homes, which homes is we argue that the name should be changed because it's become a lot more than just homes. We've seen office buildings, we've seen large multifamily, large scale buildings. We've seen offices, laboratories, all sorts of different building types. So it's not just homes as you would think of a single family home. Next slide. So a few of the major principles for passive house: insulation continuity is extremely important. We look early on, and we'll go through a little bit of the timeline for what it looks like on our end as the CPHD during the design and construction process. But we have insulation continuity and thermal bridge free construction. Now, thermal bridge free is the goal. It doesn't always happen. There's always going to be, a window detail or maybe a penetration or a balcony or something that is going to be penetrating, but our goal is to minimize the thermal bridges as much as possible. We emphasize high performance windows on both of these projects that we're talking about today. We're in the process of vetting the windows and kind of plugging all of that into the models. And it's arguably one of the toughest parts of our passive house projects, just because there's a lot of moving parts. There's a lot of standards that the window manufacturers have to report in. They self-report values, and then they have the standards that they want to or need to get their product certified in. And all of that data comes to us and we plug it into our models. Airtightness, I'll go into a little bit the differences between those metrics between the two programs, and then balanced mechanical ventilation. Go to the next slide. So this is just a little bit extra on that thermal bridge free design, an example of a detail there, not for one of these projects, but just as an example. We want to make sure that there's not going to be any condensation or comfort issues within the units and the high traffic areas. For things like corridors or infrequently passed areas, there are some things we can do. Like you might have a large storefront and in the front of a building, especially in a multifamily building, maybe it's the lobby, maybe it's the leasing office. There's things that we can do like overhead heating or baseboard heating to kind of complement those less performing systems. So passive house doesn't mean that it needs to be a boring box with no windows. We like to reiterate that because that tends to be what people think right away, but there are some really great high performing components out on the market today. Next slide. So this is just a difference between the two air tightness requirements between the programs. So with PHI, and both I'll note are at 50 pascals. So when you're doing the blower door test, we are pressurizing the building to 50 pascals, which is equivalent to about 20-mile-per-hour winds around the whole building, just to get a sense of kind of what that means, pressure on the building. But for PHI, we're at 0.6 air changes per hour, and we will hold that as the worst case scenario through design in our model. And then once the blower door test is complete, that number can come down and the final numbers can actually look better and be better for performance than they were originally modeled if the blower door test goes better than we expected. And then FIAS, we're at 0.06 CFM per square foot. Just a slightly different metric how it's plugged into the model. The 0.08 that I have there is for projects that are greater than 5 stories or non-combustible. So for these two projects, we were at the 0.06. And then this is just a visual to kind of describe again that comfort criteria or that occupant comfort. We want to make sure that we're minimizing drafts. You shouldn't be able to touch a window or touch a wall surface or a floor above a parking garage or whatever it may be and feel cold or feel that temperature difference. So minimizing those drafts, minimizing any differences, and keeping things as consistent as possible. And we like to refer to our passive houses as coolers. If you keep the lid on, then it stays as it's conditioned inside. If you pop the lid or if you leave it open and there's cracks in the building or cracks in your cooler, then the air is going to escape and the temperature is not going to maintain. And then some tips in best practices with these super airtight buildings. You've probably heard people refer to sick building syndrome or have concerns about, well, how, my building is so tight, how are people going to get fresh air? You can have operable windows in a passive house. That's not a problem at all. But also these buildings are being mechanically ventilated 24 hours a day, especially in the units. There's constant fresh air coming in, and the heat recovery along with that helps keep the building's energy use down. So there's upwards of 75, 88, almost 85% heat recovery efficiency on the units used in most of our passive houses. They come in usually around 80%. And that just means that the air leaving the building goes through a core where the heat energy can be transferred to the incoming air. So the heating and cooling system doesn't have to do as much to keep up. And the air highly ventilated, both standards have MERV rating requirements for the ventilation air to keep everything healthy and clean. And then a couple more just small points here. Aeroseal products and car dampers are both extremely important for our projects. Some sort of sealing of the ductwork to prevent any leakage. Leakage means your system has to work harder. And then adjustable car dampers, what those allow you to do is at each register or each damper adjust the flows. So during testing and balancing, and it's great to have those dampers, but they need to be accessible as well. We've seen projects where in the field, the tab contractor comes out, or our field team is in the field trying to measure flows, and they need to adjust the damper, and it somehow got trapped behind other ductwork or deeper in a wall and it can't be accessed. So accessible car dampers to readjust those flows and make sure that everything is working as intended. And then these are just more specific to multifamily buildings. I highlighted domestic hot water design just to drive that point home. Traditionally, pipe runs tend to be a little bit longer and less optimized. So for passive house buildings, especially with the PHMass program, which I'll talk a little bit about the co-requisite programs that go along with PHMass, but hot water design is very important. The water for PHMass specifically has to get hot within a certain amount of time, otherwise the individual fixtures don't pass. So optimizing those pipe runs and optimizing riser and central systems is extremely important. So that's just one thing in addition to the airtight envelope, the low mechanical usage, et cetera. So this is just a little side-by-side of the programs themselves. One of my colleagues, I'll read a quote from him. He says it's means and methods sort of idea when we're talking about the two programs. Like Christina was saying, there was no real reason they chose one or the other. You can do a feasibility for both programs through either your CPHD for PHI or PHMass can actually do a feasibility for you to see how your project will work out. So we do recommend that for maybe your first project if you've never done a passive house before, or for a more intricate or more unique typology, we definitely recommend that. But it doesn't really matter which program you end up picking, because at the end of the day, our research and buildings that are already completed, we're seeing that they're performing similarly for similarly sized buildings. But there are some small differences between the actual programs themselves. So with PHMass, for example, I talked about those co-requisite programs. That's things like Energy Star, Indoor Air Plus, the Water Sense program, and I have those on slides upcoming. There's some terminology differences between the two programs. In my introduction, I accidentally called myself a CPHC, but CPHD designer is the person who designs for a Passive House Institute. So I was trained and tested through that program, and then CPHCs are through PHMass. So I'm able to, work on both, but one of my colleagues is actually the CPHC for Hills Farms project. And then for PHMass, in the field, there is a verifier. So Christina mentioned Sustainable Comfort Inc. They're working as the in the field verifier for the Hills Farm project. And then there isn't an actual term for the person who does the in-field inspections for Passive House. But it just all of the documentation needs to be collected and submitted through PHI at the end of the process. And then the difference, there's two different modeling softwares. So PHIAS has the WFI passive program, and then PHI has what's called the passive house planning package, PHPP. I like to throw those around. Nobody ever knows what I'm talking about when I'm on calls with a new team. So we try to keep all that straight, a lot of terminology, a lot of acronyms, as there is across the whole building field. And then when it comes to actually submitting the project for certification, PHIAS you go directly through PHIAS, and the CPHD acts as the expert documentation collector for that. And then PHI, we submit through what's called a certifier. So that's a third party. So our firm, we have a certifier on staff that is the director of our team, but she cannot be the certifier for the same projects that she is the CPHD on, as it would be a conflict of interest. So just a little bit about the terminology. Don't want to get too in the weeds there. Happy to answer more questions about that later. And then these are just a few things that we've seen across the two different programs. And there's a big asterisk on the double paned windows. That's not something that we're seeing as much in our climate, especially Massachusetts. It was perceived for some time that PHIAS had slightly looser requirements that allowed the windows to be double pane in some cases. And you can still get away with double pane in some cases, depending on the size of your building. But then with PHI, there's a slightly looser leakage limit based on the overall size of the building. If you look at it on an apples to apples comparison for the air changes per hour. So there's some differences between both. They kind of come out in the wash at the end of the day. But we're seeing, triple pane windows on most of our projects, and they're like the highest performing windows that you can find on a lot of our projects to maintain, especially in Massachusetts, the heating demand. That's the toughest thing to beat for passive house because it's a heating dominated climate. So then a few other just intricacies, PTHP units, which is something that we're seeing a lot more of used on upcoming projects. PHIAS allows you to tape those off during your final blower door testing. Whereas PHI, you end up with a higher infiltration rate when the PTHPs are used because you can't do that separate taped test. And then one more thing to note, I know a lot of what's happening in Massachusetts, the code is geared towards new construction, but PHI does have a separate retrofit pathway, which is what Christina mentioned before for 200 Tyler, the retrofit senior housing project. So.
And I will add, PHIAS is rolling out the Revive program, so their retrofit program as well. It's currently in a pilot phase.
That's awesome. I did not realize that. So hopefully we'll be able to make these even more equal as the need for passive house continues to grow. So this is just a list. I know there's a lot of words on this slide, but these are some co-requisite programs that go along with PHIAS. So the verifier on this Hills Farm project is going to be communicating with SWA and kind of taking on this field verification stage for this project. So we have Energy Star. So that's anything, we look at appliances, we look at internal loads and all of the loads that get plugged into the model. Zero energy ready homes, and that goes along with electrification readiness, which is something else I'll briefly mention in a minute. Indoor Air Plus, and then the PHIAS multifamily workbook, the verifier or the on-site will generally do that as well. So the projects that we do both, we have that scope within SWA as well. But I will note our passive house team does not do the verification work. We have a separate team. You can't be the CPHC and the verifier, similar to you can't be the CPHD for PHI when you are the certifier. So both have separate to avoid conflict of interest, and it's just that extra set of checks and balances to make sure that these are running as they should. So the electrification readiness, as Christina mentioned, these two projects, and then for Fias, particularly Hills Farm, has the DHW with gas boiler. So there are requirements that, and I do not remember off the top of my head, but there are outlet requirements and electrification to the building requirements that ensure that it is electrification ready. And that goes along with Fias 2021. Yeah, and that applies to all things across the whole building.
So in the case of Hills Farm in Shrewsbury, we had to size the electrical service into each building to basically accommodate in 10, 15, 20 years, whenever the gas boilers fail, we'll be able to not replace them in kind, but basically decommission them and install instead a heat pump water heater plant. And so there's adequate electrical capacity. There's also physical space for potentially added storage needed if needed, and rooftop space for the outdoor condenser units. So that's all kind of direction that Kate and SWA gave to BLW, our mechanical and electrical and plumbing engineers, who were designing a domestic hot water plant using gas. But they also had to keep in mind almost this sort of future looking scenario and design for that, just leave the equipment out today, which I'm finding new projects that are starting now, because you're sizing your transformer and your switch gear, and you're providing the breakers and spare conduit, the sort of solar PV ready kind of strategy for domestic hot water. We're finding we may as well just finish the job, right? Finish that work and commit up front to electrifying the domestic hot water plant. Maybe a strategy of Fias, I don't know, but it's working on all the new PHMass projects of ours.
Great, thank you for adding that. Yep, and then so with Fias as well, there are EV parking requirements as part of 2021 program, and it's based on the building's parking requirements. So how many spaces you are to have for your parking lot, X% of them based on the chart has to be EV ready, and then there's EV capable. So EV ready is on site day one, able to charge vehicles, and then the EV capable, similar idea to the electrification readiness, the size of the electrification is there, and there's access to panels and things that could make that X number of spaces able to be converted to EV ready along the line. So then we'll go into a little bit about the certification requirements for the two programs. So with Fias, there's 4 load/demand related requirements, all have to be satisfied. So that's heating, cooling, demands, and loads. And then there's a source energy requirement, and then that air tightness requirement that I mentioned earlier, in addition to the co-requisite programs and the multifamily workbook. So that SNP is from the Hills Farm project. The red X, don't let it scare you. It's because currently we are in the process of switching to the new WFI 2021 program. And the previous program did not have the correct source energy. So on the next slide, you can see we use this calculator to populate the thresholds that get plugged into the model, as well as the source energy. So we ignore the one that's actually in the model for now until we switch to WFI 2021, and we use the one that is here. So they are passing their source energy. And this, both are based on climate. So you see I plugged in there Massachusetts in the closest climate zone, which is the regional airport. And it's building size specific. So it's based on the number of dwelling units, the density of the building, and the envelope area. And then for PHI, we have heating demand and cooling demand. You'll see those in the chart below. but they are alternative criteria. So we actually only need to satisfy the heating demand and the cooling demand for our projects. And then there is our source energy is called PER or PE demand for the apartments project. We have the PE demand, and typically that's used when there is a gas unit still in the project. PER is PE renewables. So if the building was fully electrified and had the ability to offset use with PV or otherwise using renewables, we would use that other version. And that allows you to get to higher levels of PHI. So there's PHI Classic, which is what this project is going for. And then there's PHI, I'm blanking on the other versions of the program at the moment, apologies. But there's 2 higher tiers above PHI Classic that if you are doing the PER method and you have a fully electrified building and you have PV or other renewables, you kind of go up on the scale, which allows you to get to those higher levels of passive house. And then the air tightness requirement as well. So what I did here was I broke out just so it's a little bit easier to see the threshold, which, as I mentioned, is climate or project specific. And then the project result in that middle column. And then I did the percentage of total threshold just so that you could see just how heating dominated our climate in Massachusetts is. So both are in the mid to high 90s of the overall threshold. And it's been a challenge. Christina will know, like, we've gone back and forth on the window products. Probably I've spent, I don't know how many hours on it in the last just week, trying to inch down that heating demand before we go into construction, because when we're in construction, if things aren't aero sealed or if there's leaks that weren't expected, everything kind of chips away at the heating demand. And that's just the nature of how these projects work. So we want to make sure we're set up for success as early in design as we can. And then I'll mention as well, so we're talking about building 2 for Hills Farm, the smaller of the 2 buildings going for FIA certification. And those 2 buildings just within themselves are kind of in a battle, heating versus cooling. So the larger building, building 1, with the same components that building 2 has, because building 2 is struggling to meet the heating demand. So it has that beefier roof, the beefier construction. That's actually hurting the cooling demand of the larger building. So it was a little bit of a battle, a little bit of a dance to get those 2 both in compliance at the same time. It's something we've hoped for, and maybe it'll be something that comes along down the line, maybe not, but something more campus wide when there's more than one building in a development. There's a couple other projects that we're working on in Massachusetts right now with several buildings all trying to get passive house at the same time. It's almost impossible for them to all be the same because the orientations are going to be different. The number of units is going to be different. But everything down to the landscaping, like if you know there's going to be a large line of trees up against the north side or the south side rather of a building, anything that causes these buildings to get less or different sun exposure can affect that. So it's a little bit of a dance. It's very interesting to see how these multiple building developments kind of come together at the end.
The only thing I'll add here, Kate, is just again, is the owner and developer's perspective. Kate's chasing down and pinching and balancing everything she can on the back end as we're advancing through design development and construction documents and permit sets and conformance sets and bulletins 1, 2, and 3 and so forth. Something that I love about both of these standards is just passive house as a building science standard, and having someone like Kate on the team is that she is seeing in real time our energy modeling results and catching us basically before it's too late and making recommendations. So it's a phone call to the architectural team or to myself or whoever. Hey, your heating demand is really close. We're barely inching by. Is there something we can talk to the window manufacturer about? Or, could we get Peterson Engineering on the phone and look at tweaking some ventilation flow rates in these amenity areas and put them on an occupancy sensor, really kind of getting creative at problem solving. So it's not just here's your checklist with a big red X on it, good luck. It's more iterative, and it's really baked into the design, and everything interacts with everything else. So anyway, just thought I'd add that in there. And this is also just me projecting my anxiety over how close our heating demand is, and that reminding myself and those on the call that we have a couple of options in play right now that we're currently working through.
Yeah, that's a great point. It's a lot of moving parts, and that's what we're here to do as the CPHD is problem solve. We're here to make it all work together. We don't want to make a restrictive building. We want it to be a beautiful building. We want it to be a functional building. And from your end, from the owner operator side, it's got to be a marketable building. It's got to look nice. It has to have the amenities that people are looking for. So all of that has to come together. And then, so just one more thing on this slide, I did pull the EUIs, the site EUIs from each of these projects with an asterisk, with a disclaimer that it's based on what the modeling softwares are predicting, and both predict them in different ways. So I had to extract those. One is based on TFA, one's based on gross area. So right now, as they are 16.0 and 17.9, those are both based on the gross area, and I pulled them into the same units, but they tend to be lower than we actually see buildings operate. So if your building is not at that point post modeling, don't fret. A lot of our buildings are in like the low 30s range, especially for multifamily, mid-sized multifamily buildings. And a couple reasons for that. The assumptions for DHW across both programs, it's saying 6.6 gallons of hot water per person per day, just as one example. I know myself, I take at least a 10-minute shower. If you're using 1.5 gallons a minute, granted, that's not all hot water, but just think how quickly we use water in our day-to-day. So 6.6 is it's under expecting, it's under predicting how much energy for hot water. And then things like the set point temperatures that are built into the standard, you have 68 degrees for heating, 77 for cooling. People in the buildings might want their cooling temperature lower at night, or they might not want their house at 77 degrees in the summer when it's humid out. So all of that plays into the actual operation of the building and how it differs from what there's limitations to these softwares and what they can predict based on just climate alone and what we're plugging into the models. And Christina, you'll love this. The closest one of our projects actually to the predicted EUI based on the PHPP model was the Tyler. And I don't know if it's because it was elderly housing and, they're using less energy, not necessarily, but typically using less energy, or they want their house a little bit hotter than others might in a typical multifamily building. But I thought that was pretty interesting that the for a retrofit especially is using close to modeled operation.
Yeah, we're very proud of that. I will say that we use Mitsubishi's central controller on the VRF system there, and so we're able to pretty effectively lock in temperature set points and heating and cooling, which is useful and more difficult to do when you have individual air source heat pumps at the apartment level. I can't get rid of this little bar, so I'm sorry I keep moving it back and forth. This is just a quick kind of insert. Kate talks a lot about the two programs sort of side by side and presented on some project specific details. This has all happened, the analysis and the energy modeling updates and the pre-certification submissions have all happened over the last 18 months or so during design development. And this sort of process is not going to be the same for all projects. So we spent the better part of 2.5 years or so local planning board approvals, you know, on these projects and on most of our projects, to be honest. And the our building in Swampscott looks totally different today than the building I brought to SWA 4 years ago for that PHI versus FIAS feasibility study. You know, it's a different shape, it's a different height. The windows, you know, operability and are different. Things change along the way. But that's why we think it's really important to get your whole team on board and committed and really kind of develop roles and responsibilities around our performance objectives up front. And it's especially important as we work towards these competitive tax credit applications. And for those applications, we need to have, you know, the evidence that we're designing and budgeting a building that's going to be what we say it's going to be. And so that you know, we're not just checking off a box and saying our building is going to be Passive House certified. And as this becomes code, even that kind of thinking and process is definitely going to evolve pretty quickly here. But for us, we were, and thanks to the Mass Save feasibility study incentives, we were, in the case of Swampscott, we were able to, you know, engage a third party and do this energy modeling and make sure that we were starting out on the right foot in terms of, you know, roughly what does our continuous installation need to be, and roughly what does our window U value need to be, and will we need solar or not in order to meet the source energy. Those like really high level but super important and sort of scope and budget impacting questions can get answered up front, and we prefer to do that as early as possible in the process, so that when we're submitting applications for funding and we're working on our own pro forma and underwriting, you know, we're basically not lying to ourselves, and we know exactly what we're going to need to develop and design. And then, you know, as I think most folks on the call probably understand, the design development process itself is long and involves multiple consultants. And I haven't even talked about structural or civil and all the other consultants that the architects are managing. But we tend to see 3 or 4 different sets, you know, published, and we have to make a decision around when we have our consultants reviewing those sets. We want them to be detailed enough to sort of get substantive feedback and direction, but not too much so that we have to redesign something. And so that's kind of an interesting balancing act. I'd be happy to talk more about both of these projects. As I mentioned, they'll be closing and breaking grounds, you know, in the very near term. They have not only conformance sets, but they have, I believe it's 2 bulletins and a 3rd on the way. And that's, you know, that's pretty normal. That's in part based on RFIs and feedback and just coordination needs. But it's also in part based on feedback from FIAS and from PHI. They may catch something that we didn't catch, or have a question about something and need it more detailed, and therefore we're developing those details and working out those details, really just to ensure what we're drawing and budgeting is constructible and that it's going to work as much as we possibly can control, without getting into, you know, means and methods and things in the field. And sorry. Yeah, I guess I think that's all I wanted to add here. Kate's going to get more into construction and the sort of inspection checklist for the 2 programs.
Sure, yeah. So behind the scenes, you did a great plug. Get everybody involved early, whether it's your passive house designer or you know, as early as DDs. You can get your certifier or contract with FIAS to get them on board, especially if it's a unique typology building. It's worth getting them on board to ask them questions or flush out any maybe threshold questions, or I know for some larger like office type buildings or unique internal gain buildings, you can request a modified PE threshold. So there's things that can be done that if you get involved early, can help your overall process. And I will say a lot of times, more so with our retrofit projects, having an enclosures consultant on your team is a great idea. Even if it's just for a feasibility, for them to help you poke around with what's already in the walls. Is there any condensation risks from the existing building, things like that. So that's just a plug for retrofit projects if that's in your wheelhouse and what you're going to be working on. So yeah, so just a brief, I won't go through all of these items, but just at each stage, we get involved as early as schematic design, as Christina mentioned, and we start making suggestions, we start detailing things, we give, very in-depth feedback on the air barrier and the architectural set to make sure that everything's drawn clearly. And ultimately, we just want to make sure that it gets built as expected and performs really well. So we get involved early, and then 50% CD, mid-CDs is typically our largest and most in-depth review. And that's kind of where we start to flesh out things like, are there any closed off areas in the building that are going to be an issue in the blower door? So our field team starts to think about their blower door test plan. We work on all of our thermal bridge modeling for any unique project specific areas or details. And then 100% CD, we're kind of closing up things, tying up loose ends, picking products, talking with manufacturers to get data, and kind of buttoning up those final things. And like Christina said, sometimes it's a bolt-in or 2 or 3 to finally get everything all buttoned up and ready for construction. But we just want to make sure that headed into construction, we're good to go and everything's going to go smoothly. So these are just a couple examples of comments from these 2 projects reviews specifically. So the first one there on the top left, I had flagged the water design requirements. So we're working right now with BLW to kind of optimize the water pipe links, and then also make sure that the demand recirculation learning based system is installed in the centralized system as per the ZERH requirements. And then on the bottom there, you see just making sure that the plans match the mechanical set. We do a ventilation calculator, and we make sure all the flows are as written and match up across the whole set and is matching what we have modeled. And then an example of just an architectural detail, we will make suggestions. Is there a better cavity fill insulation that we know, that's a tough spot to get into, and if you fill it with this, then there might be gaps that you don't see, and it might cause for air infiltration that you didn't expect. So just anything to make the building as airtight as possible, especially with these wood frame projects. We just want to make sure that all the nooks and crannies are taken care of. So then differences between the actual review process itself. So SWA as the CPHC will fill out a contract request on behalf of the client, but then it gets sent directly to the client from PHMass. And once that contract is signed and paid, then we get put into what's called the review queue. So we get assigned a project number, and then the CPHC can put your project in the queue for you. And then you have X amount of days to gather your documentation for your first review, submit that. So it's kind of on a rolling basis. So you can see there, it's kind of small, but rounds 1 through 4. We've seen on average 4 reviews with PHMass. And sometimes towards the end, they can feel a little bit tedious. It's kind of a little bit back and forth, but we try to really bulk as much documentation as we can into the early reviews as possible so that we get the most out of those reviews and those timelines, because the earlier reviews do take a little bit longer. So it's 6 to 8 weeks or 4 to 6 weeks for rounds 1 and 2, kind of start to finish. So when you get yourself on the queue to when you get your comments back. So we actually were expecting comments today for round 2. So we'll see if we got those from PHMass for Hills Farm. But yeah, so that's process 4. And I did put the link there if you wanted to kind of take a gander through PHMass's website and where that happens on their site and what the queue kind of looks like. That link is there. And then for PHI, similar process. The CPHD collects all the documentation. We reach out to any number of accredited certifiers for quotes and connect them with the client. We give them a sense of how big the building is, what the typology is, and they produce a proposal. And then the number of reviews is not set in stone. It's project specific. For example, a few of the projects that we are the certifier on as a firm chose to only do a preliminary kind of talk through the building and then to do one DSR at the end. So we typically recommend 2 to 3 reviews, one in mid CDs and then one closer to the end of design, just to spread out. And like Christina said, how much has changed since the beginning of the inception of Elm Place project. So we kind of, it helps us to capture more and spread out those reviews, but number of reviews is project specific. And then the CPHD will submit our documentation directly to the certifier through what's called the certification platform or the PHI portal. And I included a link there for the list of accredited PHI certifiers. You can search by location. You can search by individual firm. So that's all there.
And our certifier on our Swampscott project is RDH. And so RDH is sort of functioning on PHI's behalf and doing similar review QA/QC of SWA's submission as PHIAS is doing directly on the Shrewsbury projects, right, Kate?
Correct, yeah, and that's good to note because when I searched RDH on that link, it didn't come up right away, but it's because they are actually in Vancouver. So you're able to act outside of your realm. It doesn't, like PHI is in Germany, so like it doesn't matter where the location is for the certifier because they're not actually on site for PHI. So as long as they're able to review and there's no limitations to time zone or communication or anything like that, then all of the certifiers are on the table, which is good because we're going to need a lot of people to review a lot of projects as Massachusetts continues to roll this out.
And it is another, again, the experience is very similar to the owner for the program, right? So your CPHD or CPHC is really shepherding a lot of this. They're getting inputs and documentation from your design consultants, maybe from your GC via subs and manufacturers. From the owner's perspective, I got a proposal from the PHI certifier from RDH, and I had to sign their contract and pay them a fee in order for them to start their pre-certification review. In the same exact way as I had to sign a contract and prepay a fee to PHIAS for them to start reviewing what SWA has been working on. So you really do have to, more earlier than I had expected, to be honest, directly engage, contract, and transact in order for your project to be even added to the queue or added to the platform.
Yeah, and again, get everyone involved as early as you can, even if it seems earlier than necessary, because it just gets the ball rolling. Even if things don't get signed right away, it just kind of helps get everything out on the table. All the prices are up front. You kind of know what you're looking at. So then this slide, I'm not going to go through this. It's just in our construction phase, what happens. Whole building blower door tests will happen at the end of construction. The testing and balancing, for PHI projects, we're on site. I guess for both projects, we're on site, kind of making sure that those are happening. And then we receive the report, and that kind of gets plugged into our final as-built model. Verification of fixtures and appliances. So SCI will, Sustainable Comfort Inc. will take care of the in-field verification for all of the co-requisite programs for the Hills Farm project. And that'll be things like testing how quickly the water gets hot at certain fixtures and making sure that all of those things are taken care of. And then final documentation and submission to the certifying body. And throughout all of that, throughout construction, we're reviewing submittals, we're doing site inspections. On the next slide, I'll have you jump to the next slide. This is just a photo example. We do compartmentalization blower door tests for PHIAS. That's a specific requirement for PHIAS. But our guarded tests, if you have a part of the building that's unique, or maybe an office building connected to retail and some portion of the building is not going to be certified, you might do a guarded blower door test, which is during construction. You might need to close things off and test as you go. It was kind of like that with the Tyler, Christina, we did like the phased blower door testing because one part of the building was behind in construction, things like that. But this is just an example of some window testing to make sure that we like to see the first installed thing of each iteration. So, first window, we want to get a test on that and make sure that it's airtight to what we're expecting per square foot. And then, if all the rest of them are built just like that, then you're good to go. So that's sort of a little bit of a look into our on-site experience.
And this blue highlight here, it's blue because it's PHMass and not PHI, as you said. And just to elaborate a little bit, to me that is probably the biggest difference, which are the co-requisite programs as Kate described earlier. So Energy Star and Zero Energy Ready Homes, which you might be used to if you're building a LEED building. It requires Energy Star also. So it's kind of similar in that way. But in addition to the whole building blower door test that you have to do for PHMass and for PHI, PHMass uniquely also requires compartmentalization testing of each apartment. So you're considering, odors and air transfer and also sound transfer from unit to unit and units to corridors, which, we've all been doing for code for many, many years now. So it's not new or different, but it is unique to PHMass over PHI.
Yeah, and that just lends itself even further to the comfort, like you mentioned, odors from unit to unit, sound. PHI doesn't necessarily exclude all those things. A tight building is a quiet building. A tight building is a clean building, but that is one of the largest differences. So this is just an example of our inspection checklists that we would issue right around construction. These are actually from the Tyler. That was not just a coincidence. It was just in our slides. But yeah, so we would issue those as part of our construction package. And that's just for the on-site to know what they need to do along the way.
And I guess, can you talk a little bit about pre-construction, because this is where we're at right now on both of our projects, the sort of training and kickoff meetings that you would recommend doing with the general contractor and then again with the subcontractors?
Sure, yeah. So we can do an on-site kickoff at the beginning of construction or prior to construction. We try to do it as close to the start of construction as possible so that it's fresh in the brain for all the staff on site. We usually recommend having somebody from the general contractor who is solely responsible for passive house. This person's going around and making sure that the thing that we saw in our last inspection is getting completed. It lends itself well to having somebody who has that lens, that passive house lens, and can kind of keep everybody else on track. So we'll do a pre-construction kickoff meeting. We'll go through the blower door test and what's going to be involved in sealing the building and making sure that we have a time set for that particular inspection. And then as far as training in the field, we do mock-ups, like our field team will come out and do mock-up training. So that might be a window that's not actually installed in the building, it's installed near the building, and it's just to show the people who are actually going to be doing the installation what they need to seal, where things need to get caulked, what does it look like to seal off a penetration through the air barrier, what does that actually have to look like, et cetera, et cetera. So I hope that answers your question, but just in hands-on stuff that we want to make sure people are aware of who might not be used to working on passive house projects.
Yeah, and I want to wrap up the last couple of slides here so we have time for Q&A. Everything we just talked about, it's started early on in local planning reviews. This is when a project might go from 6 stories to 3 stories to 4.5 stories, kind of big picture concepts like that. And then you get into, pen to paper design and engineering, you're updating your energy modeling, it's iterative. We're getting the project financed, we're closing. This is where, both of these projects have been for the last year and a half, and we're pricing and designing and pricing and modeling all as a team with real-time kind of feedback along the way. And then we're super excited to start building them. So we've been talking about them. We've been design review, page turn after page turn, and now we're going to be kicking off construction here in a little bit and get into the closeout process. And maybe in a year and a half or so, we'll be presenting on the construction phase and the closeout phase and what we learned from that. So this is sort of just wrap up. I think to reiterate, we've found that the Passive House standard is really useful in sort of establishing a vocabulary and definitions and guardrails around everything that we're talking about. There's nothing kind of wishy-washy or unknown. It's a design and building science standard prioritizing comfort and low energy use, and that translates into good building envelope design and high performance HVAC systems. You can really kind of simplify it in that way, and it just becomes good, high quality design with a level of oversight that is unique, or it has been unique over the last decade or so, and I think it's going to become, frankly, necessary as more and more projects pursue Passive House as an energy code compliance path, which I hope that they do. We've learned a ton from these first two projects, and WIN has another 6 or 7 in our pipeline behind these two that frankly look very similar, and that saved us a lot of time and concern and risk. So the more we do, the sort of more we de-risk this. That's not to say that the stuff isn't expensive and takes time to do, but I think we're really confident that the Delbrooks and the Cranshaws and the TAT and Cube 3 and Steve Winters and New Ecology and SCI, all this wonderful growing industry, in large part supported by Passive House Massachusetts, is going to be here to support us and our peers along the way. So with that, I'll leave some time for Q&A, hopefully. Thank you.
Thank you, Christina and Kate. That was a tremendous presentation. We went over a lot of information, and there may be some good questions here. So we're going to open it up. Folks, you can use the chat room to type in questions. You can also use the raise hand feature to ask them directly. So please go ahead and let us know what you'd like to know further from Christina and Kate.
I'll jump in. It looks like there's already a question from Jared in the chat. I think for the electrical capacity, I think it was a mix, and Christina, you can correct me if I'm wrong. I think some was leaving room for future conduit and future electrical capacity, but then other things like with the EV, ready EV, I think a lot of that was already there. It's just whether or not it's set up to be able to charge a car right now. And then, did you want to add to that, Christina?
Yeah, I think the future, the room that I was talking about in the conduit is for is just that, like physical space and empty conduit, and that's for equipment that doesn't yet exist, but the transformer, all of the panels, the switch gear, that is included in the project on day one. So we won't have to retrofit or replace any of that infrastructure that hopefully is sized to support the building for 50+ years.
And then we at SWA are hoping to get more into it. We haven't done a lot of embodied carbon modeling to date, but it's something we're talking about for the future. So I'd be interested as well to see if the windows, with anything, whether it's in 2 extra inches of insulation, it might help the heating demand, but is it impacting the embodied carbon of the building in a negative way? So it'll be interesting to kind of get more into that modeling and become more well-versed in that. So more to come on that.
Great, thank you.
Absolutely, us too.
Oh, sorry. Hank, you have your hand up. Go ahead.
Yeah. Christina and Kate, thank you very much. This has been a terrific presentation, a way of comparing the two projects. We've had a tendency to be focused on FIAS mostly, and it's very interesting to see a comparison of the two systems. In comparing the two, are there differences in terms of prescribed occupancy assumptions between the systems, like in multifamily, the number of people per bedroom, et cetera? Does that differ between them?
Yeah, so thank you for asking that question. That's a great point, because with PHI, and it's one of the reasons too for PHI why the EUI comes in lower than actual operation. Through PHI, they don't allow you to use the actual occupancy. It's a calculated occupancy based on the number of units. Between the two programs, the number of people per bedroom is similar. It's like bedrooms plus one. The only difference is studios are considered 0 bedrooms in PHIUS, so it's 1 person, whereas studios in Passive House Institute are 1 bedroom, so it's 1 + 1 is 2. So just some minor differences, but overall, the occupancy modeled in PHIUS is true occupancy, whereas the occupancy modeled in PHI is based on the number of units.
Yeah, this is something which I think in the past we felt was accentuated with affordable housing, because the occupancy profiles per bedroom can vary with affordable housing versus market rate somewhat, which is one of the reasons I raise it. The second question I have is, it doesn't look like either of these projects had it, but do you have projects where you're looking at the question of, can you exclude areas from the certification process? We know it happens. I'm interested in understanding more how those decisions are made with the certifying agencies, PHI and PHIUS.
Sure, yeah. So we've seen it a lot on more so on larger scale multifamily projects. A lot of time there's a podium level that has retail. A lot of our projects in the city might have public access or social services as a first level, especially in some of our affordable housing projects. And those are not always included. Things like schools, things with very different typologies than multifamily housing, because the way that works in PHI's modeling especially is you would have to break those out into 2 separate PHPP models because they have 2 completely different use types. So for the project, it's a cost thing. A lot of the times they don't have the extra budget to do 2 completely different iterations of their model based on the retail or based on the social services and then the multifamily building. As far as PHIUS goes, I think we've seen similar things. I know there's a larger scale multifamily. I think same thing, retail on the ground floor. We've seen an office, I forget whether it's PHI or PHIUS. We have an office project that is in Massachusetts, the Winthrop Center project. They are certifying their office space, but they're not certifying their residential, or vice versa. So it's some whole chunk of the building is excluded, kind of right in the middle. So that is a great point for the guarded testing and things that kind of happen during construction that need to be thought of in advance, because the construction is still going to be building the building up, but we need to blow door test a whole floor at a time. So there's a lot of sequencing that goes along with doing exclusions, but it can happen. And a lot of times it's based on use type or typology.
Kate, is PHIUS and or PHI more accepting, less accepting for those kinds of sort of unique projects requests?
I wouldn't say more or less accepting. I think it's just dependent on what the reasoning is for excluding. Like if you just don't want to do, you're not going to be able to exclude your lobby for your multifamily building. Both programs would have an issue with that because it's being used primarily by the residents. So any space that's roped in with the residential would need to be included. Whereas if there's a commercial kitchen in the technical school on the first floor, I don't think either program would have an issue with excluding that if it's a completely different use type. And then core and shell is another example where you don't know who the tenant's going to be. You have no idea what their mechanicals are going to be. It's not even fit out yet. So it's tough to have that included because you don't know what to model. And there are core and shell guidance for how, how to model tentative things, but a lot of times those spaces get excluded from the certification.
Laura has a question in the chat, Kate, that I'm gonna throw to you also. We've presented this kind of rosy picture of SWA being engaged early and providing all kinds of number of hours of involvement and design feedback and energy modeling support and reaching out to manufacturers and so forth. Is that without patting yourself on the back too much, is that standardized? Is that extra service just because Win is your favorite client? Just kidding. But is there standardization for CPHDs, CPHCs that any developer could expect is just by default included in a proposal that they might get regardless of the firm?
I think there is an overarching, we want to see your building succeed across all CPHCs, CPHDs, all of our consulting firms. But I think when it comes to kind of the smaller stuff that I talked about that we do, not all of that can be written in a proposal. There's no way to know that we're going to need to consult the manufacturer or give a little bit of an extra handhold to get some more data or whatever. So I don't want to say that's not built into our proposal, but I think that's an important thought, is to really look at the proposals that you're receiving when you're fleshing out your clients. Make sure that you have enough meetings. If you know that there's going to, if it's your first passive house project, make sure that there's extra meetings involved in that budget so that the CPHD is willing to kind of work with you and go step by step. And I think all of us, I can't speak for everyone, but I think all of the certifiers and all of the CPHDs are here to do the same thing, and that's make a really good building. We're just here to make really good buildings.
All right, I'm not seeing any other questions, folks. I'll give it 1 minute to see if anybody else has anything else to ask. But Christina and Kate, thank you so much for putting this presentation together. You shared a lot of information with us. It's very appreciated. And folks, we did record this, so if you missed some stuff during the presentation, the video will be up later this week, so you can reference it. I really appreciate the time you guys took to put this together and present it to us here tonight. Thank you so much.
Thanks for having us.
Thank you, everyone.
All right, I don't see questions coming up, so that'll be the end of it. Take care, everybody. Stay safe, and have a good night out there.